Hello everyone, I'm Rajasri, Assistant Professor, Department of EEE, working at MLR Institute of Technology, Hyderabad. And today's lecture, I'll be discussing single-phase half-wave controlled rectifier with RL load with freewheeling diode. And here, we are making use of a single-phase half-wave rectifier with RL load with freewheeling diode. And since rectifier, it converts AC to DC. It has got input voltage as AC, which is alternating in nature, which has got both positive half cycle as well as negative half cycle. And during positive half cycle, anode is made positive with respect to cathode. In that case, it will be in the forward blocking state. It will be in the forward blocking state. And the moment when it is in forward blocking state, that means it is ready to conduct but not yet conducting state. And the moment when we provide the gate triggering pulse, so-called alpha. At this particular instant, so-called alpha, when we provide the gate triggering pulse, the thyristor comes into the on state. That is, the thyristor is turned on and it started conducting current flow through the load. That is from the instant alpha to pi. Alpha to pi. The thyristor is on and it started conducting current through the load, during which the polarities across the inductor is initially the inductor, it starts charging. So the polarities will be positive, negative, and it started storing certain amount of energy in the form of voltage. So the voltage across the inductor V is given by VL is equal to L into di naught by dt. And by that time, completely energy is stored in the inductor, the polarities will be turned out to be negative and positive. So yeah, for now, thyristor is on and it started conducting current from alpha to pi, and that is how we are getting the output voltage. That is, whenever thyristor is short circuited, at that instant, whatever the voltage which we have applied will be appeared across the load. So that is the reason, that is how we are getting the output voltage right from the instant called alpha to pi. And the moment it reaches pi, negative half cycle appeared, and because of which thyristor is now turned off, and because of which the output voltage right from pi to 2 pi plus alpha, that is pi to 2 pi plus alpha, the output voltage is equal to 0. And the moment when it reaches 2 pi, again it will be coming into the forward blocking state, and now it is ready to conduct. And if we can provide the gate triggering pulse at this instant called 2 pi plus alpha, we are providing the gate triggering pulse such that the thyristor is now on and it started providing the output voltage right from 2 pi plus alpha to 3 pi. So now, coming to the output current, let us see the output current waveforms. Here, we are getting the output current right from alpha to pi. At this instant called pi, the output current is maximum. At this particular instant called pi, from alpha to pi, we are getting the output voltage or output current waveform. And if you see, current is building at a slow rate. Why is it so? Why current is building at a slow rate? It is because of the presence of inductor. Because inductor does not allow any sudden changes in the current. That is how the current is building at a slow rate and it becomes maximum at this instant called pi. And as I have already told you, inductor has a habit of storing energy. That is, it stores energy with a voltage of VL is equal to L into di naught by dt with the polarities negative and positive. Because of these polarities, if you see, now anode of the diode is positive with respect to cathode. So now this particular diode gets forward biased, and if you see, cathode of the thyristor is more negative with respect to anode. So that is the reason here thyristor will be getting turned off. Diode will be on. Diode is coming into the on state during negative half cycle, and during which the thyristor is getting turned off. Thyristor is now getting turned off. So whatever the energy stored in the inductor during this process, during the positive half cycle, whatever the energy stored in the inductor will be now dissipated through the load with the help of the freewheeling diode. The energy stored in the inductor will be circulated through the load with the help of freewheeling diode. And that is how you are getting the output current right from the instant pi to pi plus alpha. That is how you are getting the output current right from pi to pi plus alpha. And if you see the energy stored in the inductor, because it is supplying the current through the load, it is supplying the energy through the load. Whatever the energy stored in the inductor is getting dissipated slowly. That means the energy stored in the inductor is slowly getting reduced, and because of which current through the load is coming down and finally becoming zero at this instant called pi plus alpha. And again, during the negative half cycle, thyristor doesn't conduct and it remains zero. Output current remains zero. And at this instant called 2 pi, now again thyristor will be forward biased, but it will not conduct any current through the load because we are providing the triggering pulse called 2 pi plus alpha at this particular instant. And that is how again thyristor is conducting a current through the load. And now from this instant called 3 pi to 3 pi plus alpha, 3 pi to beta, at this instant, now inductor is providing the energy to the load. And now coming to the current waveform across the freewheeling diode. If you see freewheeling diode, it is conducting current from the instant pi to beta. And again from this 3 pi to beta, only freewheeling diode is conducting. Otherwise, it is not conducting. Coming to the average output voltage. Average output voltage expression, V0 is equal to 1 by T. General formula is we have 1 by T 0 to T V0 of omega T d omega T, where here time period is 1 by, every similar cycle is repeating for 2 pi, 1 by 2 pi, conducting from actual waveform is present from alpha to pi, where V0 is equal to Vm sin omega T d omega T, constant bringing it out Vm by 2 pi and integrating sin omega T minus cos omega T. Within the limits alpha to pi, we get Vm by 2 pi. This as minus cos pi, minus of minus plus cos alpha. So that we get cos pi is minus 1, Vm by 2 pi, 1 plus cos alpha. This is the average output voltage expression for single phase half wave rectifier with RL load with freewheeling diode. Coming to the V0 RMS expression, we get V0 RMS general formula we have 1 by T 0 to T V0 square omega T d omega T whole to the power of 1 by 2, where time period here is every similar cycle repeating for 2 pi. So 1 by 2 pi. Actual waveform is present from alpha to pi, where V0 is equal to Vm square sin square omega T d omega T whole to the power of 1 by 2. So here Vm square by 2 pi 1 minus cos 2 omega T by 2, integrating from alpha to pi. We get, bringing this 2 outside, Vm square by 4 pi, integration of 1 is omega T within the limits alpha to pi minus integration of cos 2 omega T is sin 2 omega T by 2 within the limits alpha to pi. We get Vm square by 4 pi whole to the power of 1 by 2. So here let me apply this root so that it will be simple. 2 root pi, and inside applying the limits, upper limit minus lower limit, pi minus alpha minus sine 2 pi by 2, minus of minus plus sine 2 alpha by 2 whole to the power of 1 by 2, which is equal to Vm by 2 root pi minus alpha, and this term sine 2 pi is 0. We get plus sine 2 alpha by 2 whole to the power of 1 by 2. This is V0 RMS expression for single phase half wave controlled rectifier with RL load with freewheeling diode. And coming to the peak inverse voltage, it is Vm. Peak inverse voltage, it is Vm. And coming to the circuit turn off time, if you see, circuit is getting turned off at this instant from pi to 2 pi, it is remaining off. So that is the reason circuit turn off time is given by pi by omega. Because here omega t is equal to pi, we get t is equal to pi by omega. This is circuit turn off time. So what are the advantages of making use of freewheeling diode? And if you see, by making use of freewheeling diode, here output current is becoming continuous. And if at all, if we can make use of a large value of the inductor, in that case, the current will not be zero. The output current through the load will not become zero. If you see from this instant to this instant, output current is zero. During negative half cycle, there is no current which is flowing through the load. If at all, if we are making use of this particular single phase half wave rectifier to the DC motor load, in that case, the output current through the motor will be intermittent, which is not desirable. So for that purpose, if we can make use of a very large value of the inductor, in that case, the output current through the load will be continuous. So that is the reason, since since here we are making use of a small value of the inductor, the output current is becoming zero at some point. Instead, if we make use of a very large value of the inductor, the output current can be maintained continuous through the load. So that is the thing, and it circulates energy stored in the inductor to load. So during positive half cycle, when the current is conducting through the load, at that point of time, whatever the energy stored in the inductor is being dissipated through the load. So whatever the energy stored in the inductor is being supplied to the load during this period when the thyristor is being turned off. And it prevents negative spike voltage across the load. That is, if you see, in previously with single phase controlled rectifier with RL load, if you see, we have seen a negative spike. Whereas here now with the use of freewheeling diode, this particular negative half cycle negative spike is been eliminated. That is the advantage. If we can eliminate this particular negative spike, we can improve the power factor in this process. So it also helps in commutation of SCR by imposing reverse voltage across them. It also helps in commutation of SCR. If you see, since the freewheeling diode has come into the picture, it has got turned on, the thyristor is automatically getting turned off, because if you see, the cathode of the diode will be more negative when compared to that of the cathode of the thyristor. So that is the reason here thyristor is getting turned off, and thereby whatever the energy stored in the inductor is getting circulated. This particular freewheeling diode is facilitating that. So naturally turn off of thyristor will be taking place. So these are the various advantages of making use of a freewheeling diode. And in the upcoming lecture, we will see single phase half wave controlled rectifier with RLE load. Thank you.